Use the comparison test to determine whether the following series converges or diverges. So we're adding up 3 to the n minus 2 all over 5. Okay. Now there's a couple ways to approach something like this. If we're going to use the comparison test, we've got to find something to compare to. But what are we going to focus on? Are we going to focus on the 3 to the n and say that, well, you know what, maybe it's a good idea to compare this to 3 to the n. Right? Try and establish a comparison that way. And maybe that'll work. Maybe we'll have to tweak it. I mean, the divide by 5 is not going to help us, so maybe we'll have to compare to 3 to the n over 5, which is also geometric. Okay, but maybe the appropriate inequality can be established. This one diverges, so I suspect this one does as well. But another approach is to just try and get a handle on this particular series. What's happening? Well, we're adding up 3 to the 1 minus 2 over 5, plus 3 to the 2 minus 2 over 5, plus 3 to the 3 minus 2 over 5. Okay. And so what's happening? Well, 3 to the 1 minus 2 is 1, and we get 9 minus 2 is 7. 27 minus 2 is 25, so that one will actually just solve itself to be 5. 81 minus 2, 79. 241. Everything here, it looks like it's getting bigger and bigger. If we weren't in the question asked to use the comparison test, we could probably just use the nth term test. But still, we should need to do the comparison test, so what could we compare to? Well, since everything keeps getting bigger, how about we just compare to the nice constant series, just adding up 1/5 plus 1/5 plus 1/5. Okay? This diverges. In fact, anytime you add up a fixed number, it's always going to diverge unless that fixed number is 0. Right? So this diverges, and let's just run through our comparison. So to do this, we have to establish an inequality. So for any n greater than or equal to 1, because that's our starting index, we can see 3 to the n is greater than or equal to 3. And so we're just slowly building up the expression of our sequence, the formula for our sequence. Okay, so this is 1. Okay. And so that's actually a pretty easy inequality to establish. Okay, not saying that if we had compared it to 3 to the n over 5 that would have been harder, but you definitely can't jump straight to this inequality, because that wouldn't be true. Okay? So at least working with the 1/5 that we're doing right here has that advantage. Okay? So this is true for n greater than or equal to 1. So by the comparison test, since the sum of the 1/5 diverges, so too does ours, which is 3 to the n minus 2 all over 5. And there we go, all set.